Quality departments are charged with ensuring the highest quality of the products their companies make. Quality events come from many sources, both internal and external. When these events happen, quality will look into how to short-term validate the quality events, contain the event and keep it from getting worse, and ultimately propose solutions to fix these problems, known as dispositions. Quality departments can disposition issues as scrap, rework, or as is through either a deviation or a waiver. Long-term, quality needs to investigate the problem to find the root cause and suggest preventative action so that the quality event does not happen again. Audit of the preventative action can be scheduled to assess their effectiveness. We understand how critical quality is to the success of any manufacturer and how close these quality processes need to be tied to their design and development processes, especially for closed-loop effectiveness. At Minerva, we have helped many companies utilize information technologies to get control of quality issues and provide critical tools to improve overall quality processes. With Minerva PLM, you will be able to track and report on statuses of all quality events, ensuring nothing falls between the cracks and that any mandatory reporting mandates are met. Containment actions can be created for complaints. You can see a complaint here. We have a complaint against the gantry. It was filed against a particular customer. We have a complaint identification number and its details. We also have the investigation date. We can also place any attachments against this complaint. And if there were communications that were sent back and forth with that customer, we could track them here. We can see the customer has basically stated that the gantry is not moving. We also have other types of quality events. One of them is a nonconformance record. Here we have a nonconformance record that indicts that the gantry is moving or not moving or moving intermittently. We have identified the affected units of production that this is happening with. And we have identified, again, the gantry as the part that we are attaching. Here we have other types of attachments. We could attach pictures or we could attach videos. Once the pictures and videos are attached, we can provide hold notices or containment actions. The hold is one of the containment actions, but we could also create a purge notice, a stop ship notice, or a recall. We could also have created a corrective action, how to fix the problem. In this case, we want to rework the problem, but we could have also stated that we want to use it as is, scrap it, return it to supplier, or issue a return material authorization. If we look at the rework order, we see that this rework order is approved, and it's a very simple effective date. And we could have very simple rework instructions, such as rework to print. We can also attach rework instructions via drawings and markups. We could have also created rework instructions inside of process planning. So this is a process plan that we have created with two operations. One of them is to remove the parts with visual instructions, and the other one is to reinstall the parts according to the rework instructions. This nonconformance now is identified, it's been contained, and a corrective action has been placed on it. So at this point, we can sign off this and disposition it as a corrective action item. Now that a short-term issue is contained and effective units dispositioned, we could turn our attention to long-term fix. We can group many quality events into a long-term fix by asking for a corrective action request, or we can directly create a corrective action plan. In this case, we're going to create a corrective action request. This is a request for a corrective action and preventative action plan. We can group many quality events into this and associate it to a workflow and approve that workflow. Here I've taken the gantry and associated all of the quality events, and I'm going to send this corrective action request to approval. And then from approval, I'm going to approve it, which will automatically create a corrective action and Preventative Action Plan. You can see that the sign-offs are done, and up at the top I have a Corrective Action Plan that's associated. Here we have a corrective action number along with the status of submitted, and over to the right we have the progress of the corrective action plan. We can see that all the quality events are contained and all the quality events have had a corrective action placed against it. What hasn't been done is the analysis or the preventative action. Here we can see that the containment and the corrective action have moved forward with the plan. In order to create a preventative action, we first need to understand the root cause. This is done through an investigation. Minerva PLM supports many investigation templates, including fault tree, fishbone, and 5 whys. Here we see how an office integration takes a 5 why template and attaches it directly to a Kappa. We will open up a document from Minerva PLM. And the type of document that we want is a 5 why document. We want to grab the template that is in the system. This is the 5 why Word template, and we want to directly link it to the root cause that we have been working along, and that is the gantry problems. Once when I say go, what this will do, it will actually take a template out of the PLM system and place this template into my desktop. Here you can see that I can then fill in these fields to provide a 5 why analysis. I have filled in my problem statement and my 5 whys. There's something blocking the movement. The movement is being obstructed. There are bolts that are in the way, and if the bolts are over torqued, causing interference from the glide to tracks, the torque requirements is set too high. New torque values need to be provided. So this was the 5 why that we did, and we're going to go back into Minerva PLM and save and store this document, this 5 why analysis, directly into the system. If we go back to Minerva PLM, underneath analysis, we see that there's now a root cause, and that root cause is there with the native Word file and the PDF. We can view this PDF, and you can see this is the PDF file that we had just created from the Word document. And the last thing that remains to be done is now to identify the actual root cause. So we can create a new root cause or use an existing one. To identify a new root cause, we will simply just type it in, and the cause number will be automatically generated for us. Torque values are too high. And we have now created a corrective root cause analysis and investigation. We can see that it's still under analysis. So if we go back to the root cause and approve it, typically there's going to be some process that will have to go through an approval process on the root cause. So everybody agrees that it's been done correctly. I'm going to go into sign off, send it for approval, and approve the root cause analysis. Once when we do that, if we go back to the corrective action, we see that the corrective action is now, the analysis is now investigated. It's contained, we have done all the corrective actions, and we have completed the investigation. Now that we have done the investigation and know the root cause, we can now create a preventative action to keep the problem from reoccurring. There are many types of preventative actions such as training, patrol plan changes, etc. But whenever possible, we will try to resolve the issue through a redesign. And that's why we will go in here and create a engineering change order to change out the process. Here we are going to select engineering change order. And we will fill in the change order, but what we want to do is to select the actual gantry as a part that we want to change. When we pull in the gantry, you can see that the impact matrix is opened. And you can see that the gantry is being used on 2 upper-level assemblies, a MakerBot replicator and a MakerBot with cover. The MakerBots are still, one is preliminary, one's from release, so we don't have to take action if we don't want to take on it. But on the gantry, what we do want to do is we want to revise it. And now if we look at the lower level parts that are in the gantry, so if we need to change those, we can revise those as well. But if I scroll down all the way to the documents that are related to this gantry, what I really want to do is change the control plan. So what I'm going to do is select the control plan, and you can see that there is a control plan Excel spreadsheet that's associated to it. I'm going to open this up and change these torque values from 10 and 13 to something that's a lot less. One of the tools I can do is I could redline this document. So I could highlight the seating torque settings and say I would like those to be changed from 10 to 8 and to 10 inch-pounds. Once when I have my red line, what I can do is I can attach this red line to the collaboration. So anybody looking at the corrective action or ECO can see what the highlighted changes need to be. Now I'm ready to work on my engineering change as soon as I place my control plan into a status called revision. So I want to revise the control plan as well. Now that I'm done, I could go in here and I could go in the sign off tab and say it's done from authoring, and I'm ready to start work. So at this point, somebody will get a task to actually make changes to the control plan. In order to show the changes to control plan, I'm going to open up Excel spreadsheet, and I am going to actually get this control plan, the native file, and work on it. The engineering change record has automatically created a new revision for me and placed it into preliminary status. I am opening up the control plan, and from here, if I want to, I can see what the discussion panel was on it. So this is the red lines and the discussions that have been placed on it. And here, if I scroll down, I can see somebody has said change from 8 to 10. So I could go into this specification tolerance area and just change the values from 10 and 13 to 8 and 10. And once when I'm done, I'm happy with it, I could just save and close these changes. Minerva PLM takes care of checking in these changes and creating a PDF for me automatically. If we go back to the engineering change and find this control plan, I'm going to do that by looking at the impact matrix, getting the part. From the part, I can see the related documents, and you can see that this is the control plan revision B. If I open up that control plan revision B and view it in our viewer, here you can see that my torque values have changed to 8 and 10 inch-pounds. At this point, the engineering change is done, and I as a user can say I'm done with my work and close out the change. If we look at the impact matrix once again, we see that the prior revisions of the gantry and the gantry control plan are now superseded. And we can see that the new revisions of the gantry and the control plan are released, and new revisions have been automatically created and released for you. Going back to the corrective action, if we update the changes here and save them, we can see now that the preventative action is set to prevented. So we have contained all the problems, we've fixed all the immediate problems, we have done the root cause analysis, and we have actually prevented or put in preventative actions from actually happening again. One last thing that we need to do now is we need to put in an audit sometime in the future to check its effectiveness. So at this point, what I'm actually doing is assigning it to a person that's within my company, Mike Miller, and I'm specifying the date that I want him to actually audit the effectiveness of this corrective action. So I Typically, these are done months in the future, and I could put in some instructions for him on how to actually do the effectiveness verification. In this case, I want him to actually audit the process of how they are actually torquing down these bolts and validate that the gantry is still moving at the highest tolerances. At a specified date in the future, Mike Miller will get the task to actually audit this information, and he will be able to actually go in the sign off tab and say corrective action is effective or not effective. In this case, I'm completing it, and once when I say complete, the corrective action is complete, and in the future, Mike Miller will be able to say whether this is effective, not effective, or partially effective. Once quality departments have access to Minerva PLM with a closed-loop quality system, they will feel in control of quality events and have tools to help improve the product long-term. The quality department will feel transformed from reactive firefighters to a controlled and systematic improvers of product quality.